Hello, bright minds! Welcome to the microscopic world of subatomic particles, where the tiniest constituents of matter play a grand role in shaping the universe. So, in this brief journey, we will venture into the heart of atoms, discovering the three fundamental players, nothing but protons, neutrons, and electrons. So, these particles, though minuscule in size, hold the key to understanding the properties and behavior of everything around us. So, let's dive into the realm of subatomic particles and unravel the mysteries of the atomic universe.
So now let's look into the objectives which we will be focusing on, which are drawbacks of Dalton's atomic theory, subatomic particles, explaining Thomson's model and its drawbacks, and lastly explaining Rutherford model and its drawbacks. So we have learned that atoms and molecules are the fundamental building blocks of matter. Different kinds of matter exist due to different atoms constituting them. Dalton assumed that the atom is indivisible. However, experiments revealed that the atom comprises mainly three types of subatomic particles, which are electrons, protons, and neutrons. We will learn about subatomic particles and the various models that have been proposed to explain how these particles are arranged within the atom in this lesson. So the first would be drawbacks of Dalton's atomic theory. Some of the drawbacks of Dalton's atomic theory of matter are given below. According to Dalton's atomic theory, atoms were thought to be indivisible, but it is now known that atoms can be further divided into smaller particles called electrons, protons, and neutrons. Dalton's atomic theory also says that all the atoms of an element have the same mass. However, it is now known that atoms of the same element can have different masses. You can observe an example which is displayed on the screen, isotopes of hydrogen, which are protium, deuterium, and tritium. And next would be the Dalton's atomic theory, which says that atoms of different elements have different masses. But it is now known that even atoms of different elements can have the same mass. You can again observe certain examples which is displayed on the screen. And now quickly let's move on to the next topic, that would be subatomic particles. A number of scientists work to make the important discovery that an atom contains charged particles. By around the year 1900, it was understood that although an atom was an indivisible particle, it also contained at least one subatomic particle, which is the electron, which none other than J.J. Thomson had discovered. Before the electron's discovery, E. Goldstein observed new radiations in a gas discharge in 1886 and named them canal rays. These radiations, which were positively charged, eventually resulted in the discovery of another subatomic particle. This subatomic particle had a charge that was like the electrons in magnitude but different in sign. It had a mass that was roughly around 2000 times greater than the electrons. It was given the name proton. The mass of a proton is taken as 1 unit and its charge is +1. The mass of an electron is considered to be negligible and its charge is -1. Later, another subatomic particle named neutrons was discovered by Chadwick. Now you can observe a figure displayed on the screen where the subatomic particles in an atom are nothing but proton, electron, and neutron. So now quickly let's move on to a tabular form which is displayed on the screen where you can see the different subatomic particles, which are electron, proton, and neutron. Who was it discovered by? So electron we know was discovered by J.J. Thomson, and similarly we have a charge given to it, which is nothing but -1.6022 into 10 to the power of -19. C is nothing but the coulomb, and relative charge is -1, and the mass is 0.00054 atomic mass unit, or 9.1 into 10 to the power of -31 kilograms. And next one would be proton, which is discovered by Goldstein. We have the charge given to us as plus 1.6022 into 10 to the power of -90, and the relative charge over here is 1, and the mass is 1.00727 atomic mass unit, or 1.673 into 10 to the power of -27 kilograms. And lastly, we have the neutron, which is discovered by Chadwick. We have the charge given over here as 0 and the relative charge is also 0. So 1.00867 atomic mass unit, or 1.675 into 10 to the power of minus 27 kilograms is nothing the mass. Now let's dive into this topic, which is nothing but electron. Electron was discovered by J.J. Thomson, right? The name of the electron was proposed by Stoney. Now you can see the details which the electron contains, which is the discoverer, the mass, the charge, the relative charge, and the electron mass ratio. The discoverer is none other than J.J. Thomson. Mass is 9.1 into 10 to the power of minus 28 grams, 9.1 into 10 to the power of minus 31 kilograms, 0.0005486 AMU, nothing but atomic mass unit. And then we have the charge, which is given to us as minus 1.602 into 10 to the power of minus 19 and minus 4.8 into 10 to the power of minus 10 electron static unit. And then we have the relative charge as minus 1 and the electron mass ratio as 1.76 into 10 to the power of 8. So now let's discuss about proton, shall we? Alright. Since hydrogen is the lightest element, its mass m is the lowest and the electron mass ratio is the highest. Goldstein gave the name proton for the particles which comprised the positive rays produced by the hydrogen gas. The proton is a hydrogen ion that is produced by the loss of an electron from a hydrogen atom. So the particle with positive charge is the nucleus. So the charge over here is plus 1.60 into 10 to the power of minus 19 and the mass would be 1.672 into 10 to the power of minus 27 kilograms or 1.007276 U. So we have the equation given, the chemical equation given to it. You can observe it on the screen. So now let's quickly jump to the next one, that would be, yes, neutron. After the discovery of electrons and protons, Rutherford predicted the existence of a neutral fundamental particle. So in around the year 1932, Chadwick bombarded the element beryllium with alpha particles and noted the emission of radiation having the following characteristics. They are: the radiation was highly penetrating. The radiation was unaffected by magnetic and electric fields. It was found to have approximately the same mass as the protons. Neutrons are neutral in charge. And the mass of neutron is 1.008930 atomic mass unit, or 1.6753 into 10 to the power of minus 27 kg, which is nothing but kilograms. So now let's talk about the atomic models, which is the Thomson's model of an atom. So in 1990, J.J. Thomson proposed that an atom possesses a spherical shape and the radius approximately being around 10 to the power of minus 10, in which the positive charge is uniformly distributed. Electrons are embedded into it more or less uniformly to give the most stable electrostatic arrangement. This model of the atom is known as the plum pudding model or raisin pudding model, or can be called as watermelon model. So the drawbacks of Thomson's atomic model are: Thomson's atomic model failed to explain how the positive charge holds on the electrons inside the atom. It also failed to explain about atomic stability. This model did not mention anything about the nucleus of an atom, and it was unable to explain the scattering experiment of Rutherford. Now that we heard Rutherford, let's discuss about Rutherford's model of an atom. So in this experiment, Ernest Rutherford allowed a narrow beam of alpha particles to fall on a very thin gold foil. Thin gold foil had a circular fluorescent zinc sulfide screen around it. A tiny flash of light was produced at the point where alpha particles got struck. You can observe the figure displayed on the screen. So, the observations which were made by Rutherford were: most of the alpha particles went straight without having any deflection. So, a few of them got deflected through small angles. A very few alpha particles, about 1 in 20,000, did not pass through the foil at all but suffered large deflections more than 90 degrees, or even come back in the direction from which they have come, that is a deflection of 180 degrees. You can observe the figure displayed on the screen. Now the conclusion would be: a small fraction of alpha particles were deflected from its original path, which indicates that the positive charge is at the center of the atom, and due to repulsive forces, deflections takes place. A very few alpha particles bounced back, which indicates that the whole mass is concentrated at the center of an atom. This heavier part is named as nucleus. The radius of the atom is very small and in the order of 10 to the power of minus 10 m, whereas for the nucleus it is 10 to the power of minus 15. The electrons revolve around the nucleus like planets revolve around the sun. So this model is called planetary model or nuclear model. And again, we have the drawbacks of Rutherford's model of an atom, where he failed to explain the stability of the atom. According to classical electromagnetic theory, the revolving electron should lose energy continuously and travel in a spiral path. You can see the figure displayed on the screen. So it must fall into the nucleus, but it does not happen. So the atomic spectrum should be a continuous band spectrum due to continuous loss of energy, but it is a line spectrum. It can't explain the electronic structure of atoms and the energies of electrons.
So before we end this session, let's have a quick recap. Coming to Thomson's model of an atom is a sphere of uniform positive charge and the electrons are embedded into it like raisins in a plum pudding. You know, in an atom, the total positive charge is equal to the total negative charge and the mass of the atom is uniformly distributed. Rutherford's nuclear model of an atom is nothing but an atom consists of a positively charged nucleus which is surrounded by electrons moving around it. And electrons and nuclei are held together by the Coulombic force of attraction. The size of the nucleus is very small compared to the size of the atom. So that was all about subatomic particles. I hope you all understood it very well. Happy learning!